What if the latest interstellar visitor racing through our solar system isn't just another space rock, but something far more mysterious? 3. I/Atlas moves at over 250,000 kilometers per hour and carries bizarre chemical signatures that challenge everything we know about comet formation. While NASA calls it harmless, could this ancient traveler be a deliberate messenger from deep space, perfectly mimicking natural behavior and masking intelligence so advanced our instruments can't see the truth? Tonight on the Sleep Lab, we explore the possibility that 3I/Atlas's journey isn't just random chance, but a cosmic enigma with a purpose we have yet to recognize. If you're fascinated by mysteries that blur the line between science and the unknown, subscribe now for deep dive documentaries that unlock the wonders and the questions of the universe, transforming what keeps astronomers awake into stories that help you drift peacefully into sleep. Chapter 1. The Impossible Visitor. On the night of July 1st, 2025, while most of the world slept peacefully under familiar constellations, an automated telescope in Chile captured something extraordinary. A single point of light racing through space at velocities that defied immediate explanation. The Atlas survey, designed to scan the heavens for potentially hazardous asteroids, had instead discovered humanity's third confirmed visitor from another star system entirely. But this wasn't just another cosmic wanderer drifting through our celestial neighborhood. This was 3I/Atlas, and it was moving faster than anything we'd ever detected from interstellar space. The numbers alone should have been our first warning that something profound was approaching. Racing inward at over 255,000 kilometers per hour, fast enough to cross the entire United States in under 3 minutes. 3I/Atlas blazed through space with a hyperbolic excess velocity that spoke of origins far beyond our sun's gravitational influence. Its trajectory carved a perfect arc through the solar system, following mathematical curves so precise they seemed almost choreographed by an intelligence that understood celestial mechanics better than we do. Within hours of its discovery, observatories around the world swung into coordinated action, their telescopes turning toward this unprecedented visitor, like flowers following the sun. The European Southern Observatory in Chile, the Hubble Space Telescope orbiting high above Earth's atmosphere, and the revolutionary James Webb Space Telescope positioned at the gravitational balance point between Earth and the Sun, all focused their incredible technological eyes on this ancient wanderer from the space between stars. What they found challenged not just our understanding of typical comets, but our fundamental assumptions about what's possible in the natural universe. NASA's official position emerged with characteristic scientific caution. 3I/Atlas posed absolutely no threat to Earth. Its closest approach, scheduled for mid-December, would occur at a comfortable distance of 1.8 astronomical units, roughly 270 million kilometers away, nearly twice the gap between Earth and Mars at their nearest point. The object followed a predictable hyperbolic trajectory that guaranteed safe passage through our solar system before continuing its journey into interstellar space. Mathematical models confirmed what orbital mechanics demanded. This visitor would arrive precisely on schedule, behave exactly as gravitational theory predicted, and depart without disrupting so much as a single satellite in Earth orbit. Yet beneath these reassuring calculations, a constellation of unusual characteristics began emerging that transformed 3I/Atlas from a routine astronomical discovery into something that haunted the quiet moments of researchers who studied it. Unlike the previous interstellar visitors, Oumuamua, with its mysterious cigar shape, and 2I/Borisov, with its conventional comet-like behavior. 3I Atlas seemed to exist in a category entirely its own. Its chemical composition defied every model of comet formation. Its velocity exceeded its predecessors by factors that suggested violent ejection from its birth system, and its timing felt almost impossibly coincidental. The James Webb Space Telescope's spectroscopic analysis revealed the first truly disturbing anomaly. 3I Atlas possessed a carbon dioxide to water ratio of approximately 8:1, a molecular signature so extreme it represented one of the most bizarre chemical compositions ever recorded in any comet. Traditional comets follow predictable scripts. Water ice dominates their composition, creating the familiar glowing tails when solar radiation heats their surfaces. Carbon monoxide appears next in the chemical hierarchy, followed by carbon dioxide and various trace compounds. The ratios tell consistent stories of formation conditions around stars similar to our Sun, of icy materials that condensed from protoplanetary disks according to temperature gradients we can model and predict. But 3I Atlas had rewritten this ancient script entirely. At distances where most comets showed little activity, well beyond Mars when Webb captured its spectrum, this object was producing a detectable carbon dioxide-dominated coma, extending hundreds of thousands of kilometers from its nucleus. It breathed CO2, like some form of atmospheric production on an industrial scale, maintaining this bizarre chemical signature despite being separated from the Sun by vast distances that should have rendered such activity impossible. The velocity problem deepened the mystery. While Oumuamua traveled at 26 kilometers per second and 2I Borisov managed 32 kilometers per second, 3I Atlas moved at nearly twice these speeds with a hyperbolic excess velocity of 61 kilometers per second. Such tremendous velocity suggested either catastrophic ejection from its birth system, perhaps the gravitational violence of a stellar encounter, or planetary system disruption, or acceleration through multiple gravitational slingshot maneuvers during its cosmic odyssey. Either scenario painted a picture of an object that had experienced extraordinary forces during its billion-year journey through the galaxy. But here's where the comfortable boundaries of natural explanation begin to blur into something more unsettling. The same velocity that made 3I Atlas so remarkable also enabled something that should have been impossible: precision timing. Computer models revealed that this ancient wanderer would arrive at perihelion on October 29, 2025, positioning itself for optimal gravitational assists from Venus, Mars, and Jupiter. The orbital plane alignment was mathematically perfect. The trajectory calculations suggested encounters with multiple planets that would accelerate the object toward the outer solar system with maximum efficiency. Space agencies spend years planning such gravitational assist maneuvers for their most sophisticated missions. The Voyager spacecraft used similar techniques to visit the outer planets, and the Parker Solar Probe employs Venus flybys to gradually spiral closer to the Sun. These represent some of the most complex navigational achievements in human space exploration, requiring precise calculations and perfect timing to execute successfully. Yet 3I Atlas seemed to be performing an even more sophisticated version of the same cosmic choreography, using our solar system's gravitational architecture like a natural accelerator designed to boost its velocity for whatever destination lay ahead. The coincidences multiplied beyond comfortable probability. Not only had this object arrived during an era when humanity possessed the technological capability to detect and study interstellar visitors, but it had done so following a trajectory that would showcase its unusual properties for maximum observational opportunity. The timing felt almost theatrical, as if some cosmic intelligence had wanted to ensure that this particular visitor would be noticed, analyzed, and remembered. NASA's scientists maintained their professional composure, emphasizing the object's natural origin and harmless nature. Their press releases struck perfect balance between acknowledging scientific significance and avoiding unnecessary public alarm. The language remained carefully measured. 3I Atlas represents a natural comet carrying chemical signatures from alien stellar environments and poses no threat to Earth or any other solar system body. These statements reflected decades of experience in communicating about potentially hazardous objects, while maintaining both scientific accuracy and public confidence. But late at night, in research facilities around the world, astronomers found themselves confronting questions that ventured beyond the comfortable realm of peer-reviewed certainty. What if the very perfection of 3I Atlas's natural disguise represented something more deliberate than random cosmic coincidence? What if its unusual chemistry wasn't the result of exotic formation conditions, but rather the signature of propulsion systems we couldn't yet recognize? What if this ancient visitor had been traveling not aimlessly through the galaxy, but toward a specific destination, our solar system, for reasons we were only beginning to suspect? The answers to these questions would determine whether 3I Atlas represented humanity's most significant astronomical discovery or something far more profound, our first encounter with intelligence that had been watching, waiting, and planning for far longer than our species had existed. As October approached and this impossible visitor continued its precisely calculated approach toward the inner solar system, the line between natural wonder and cosmic anxiety grew thinner with each passing observation, each new spectrum, each perfectly predictable orbital update that confirmed this ancient wanderer was behaving exactly as something under intelligent control should behave. Chapter 2. Chemistry of Deception. When the James Webb Space Telescope turned its infrared gaze toward 3I Atlas on August 6, 2025, it revealed something that should have been impossible. The spectroscopic data streaming back to Earth didn't just challenge our understanding of comet chemistry, it rewrote the fundamental rules entirely. What Webb discovered wasn't merely unusual. It was a molecular signature so extreme that it forced astronomers to question whether they were looking at a natural object at all. The numbers tell a story that defies explanation. 3I Atlas possesses a carbon dioxide to water ratio of approximately 8:1, making it one of the most CO2-dominated objects ever observed in our solar system. To understand just how extraordinary this is, consider that typical comets follow predictable chemical scripts written billions of years ago during their formation. Water ice dominates their composition, sublimating at modest temperatures to create the classic glowing comas we associate with these celestial wanderers. Carbon monoxide appears next in the sublimation sequence, followed by carbon dioxide and trace compounds. These molecular ratios tell ancient stories of formation conditions, thermal histories, and evolutionary processes that shaped these objects in the cold depths of their birth systems. Yet 3I Atlas has torn up this cosmic playbook entirely. Instead of the expected water-dominated signature, it breathes carbon dioxide like some impossible atmospheric factory operating in the vacuum of space. When most comets at similar distances from the Sun would show little activity, 3I Atlas was producing a detectable CO2-dominated coma, extending hundreds of thousands of kilometers from its nucleus. This isn't just chemically unusual, it's energetically impossible, according to our current understanding of how comets behave at such distances from solar heating. But here's where the mystery deepens into something far more unsettling. The precision of this chemical signature raises questions that extend far beyond planetary formation theory. What if this unprecedented molecular composition isn't the result of alien stellar environments, but alien engineering? What if we're not observing the remnants of some exotic protoplanetary disk chemistry, but rather a propulsion system so sophisticated that it can operate for billions of years, while appearing completely natural to our instruments? Consider the engineering challenges that would be required to maintain such a system across interstellar distances and geological time. Any civilization capable of creating billion-year operational technology would need to solve materials science problems we can barely comprehend. They would require substances more durable than diamond, energy systems that remain functional longer than most stars burn, and manufacturing processes that could bootstrap complex machinery from the raw materials available in interstellar space. The very success of such engineering would suggest technological capabilities that dwarf anything in human experience. The carbon dioxide dominance that makes 3I Atlas so chemically anomalous could theoretically serve multiple purposes for an advanced intelligence. CO2 sublimation provides a gentle, controllable thrust mechanism that could make minute course corrections while leaving signatures indistinguishable from natural outgassing. The gas production creates a perfect camouflage coma that obscures the object's true surface features from telescopic observation. Most ingeniously, the chemical signature itself provides a form of steganography, information hidden in plain sight within what appears to be natural molecular emissions. This possibility becomes even more intriguing when we consider the observational challenges that 3I Atlas presents. The object was detected at over 3 astronomical units from the Sun, well beyond the distance where most natural comets show significant activity. Yet it was producing enough CO2 to create a coma, visible to our most sensitive instruments. The energy requirements for such distant activity should be prohibitive for a natural object, unless internal heat sources are operating according to principles we don't yet understand. Several theories attempt to provide natural explanations for this chemical anomaly, each more exotic than the last. Perhaps 3I Atlas formed near its natal star's CO2 snowline, where carbon dioxide preferentially condensed from the protoplanetary disk while water remained in vapor form. Alternatively, billions of years of cosmic ray processing could have modified its surface chemistry, creating radiation-processed crusts that seal water deep within the nucleus while allowing more volatile CO2 to percolate through microscopic channels to the surface. A third scenario involves insulating dust mantles developed over geological time, acting like cosmic thermal barriers that prevent water access to surface heating while allowing carbon dioxide's more volatile nature to respond to even minimal temperature increases. Each of these explanations requires increasingly unlikely conditions or processes to account for the extreme CO2 dominance that Webb observed. Yet what if all these natural explanations, however scientifically plausible, miss the most profound possibility? What if the chemical signature we're detecting represents information encoding rather than simple sublimation? Advanced civilizations might have discovered ways to embed data streams within molecular emissions, creating a form of chemical communication that appears natural to primitive observers, but carries structured information for those sophisticated enough to decode it. The precision of Webb's near-infrared spectrograph provides molecular fingerprints with extraordinary detail. When sunlight heats 3I Atlas's coma, molecules emit light at specific wavelengths that reveal not just chemical composition, but potentially much more. The observed 8:1 CO2 to water ratio represents one of the most extreme molecular enhancements ever recorded in cometary observations. But when we push beyond spectroscopic measurements into speculative territory, what if these wavelength patterns encode mathematical constants, star charts, or technological blueprints that we lack the sophistication to recognize? This isn't entirely without precedent in our limited experience with interstellar objects. Comet C/2016 R2. Pan-stars also displayed highly atypical volatile ratios, with unusual carbon monoxide and nitrogen concentrations that challenged standard formation models. The emergence of chemical outliers across multiple objects suggests either more diverse comet formation processes than our theories assumed, or perhaps something more deliberate, a pattern that points toward purposes extending beyond natural explanation. What makes 3I Atlas particularly intriguing is that it represents chemistry from entirely different stellar environments than anything we can model based on our solar system experience. While pan-stars formed under conditions we can theoretically reconstruct, this interstellar visitor carries molecular signatures from processes around different stars, possibly billions of years ago. It's delivering alien geology directly to our cosmic doorstep. But what if this delivery is less accidental than we assume? As 3I Atlas approaches its October 29th perihelion passage, solar heating will intensify dramatically, potentially revealing deeper compositional layers through changing thermal penetration. Standard models predict that if water ice lies beneath CO2-rich surfaces, the molecular balance should shift as internal temperatures rise. But what if these changing chemical signatures reveal not random heating effects, but systematic activation patterns? What if we're witnessing the controlled awakening of dormant systems that have waited billions of years for precisely this moment of solar proximity? The implications extend far beyond this single object. If interstellar visitors routinely display exotic chemical compositions, it suggests that planetary formation around other stars produced vastly wider chemical diversity than exists in our own system. The CO2-rich environment that shaped 3I Atlas might represent common conditions around certain stellar types or evolutionary stages we've never directly studied. But as we stand on the threshold between scientific measurement and pure speculation, the most unsettling possibility emerges. What if these exotic compositions don't represent natural diversity at all, but rather technological signatures that we're only beginning to detect? What if the chemical fingerprints we're cataloging across multiple interstellar objects represent markers, beacons, or navigation aids left by intelligences that achieved interstellar capability when our galaxy was young and chaotic? The chemical detective story of 3I Atlas challenges not just our understanding of comet formation, but our fundamental assumptions about what constitutes natural versus artificial phenomena in the cosmos. As this ancient wanderer continues its approach toward perihelion, carrying its impossible chemistry deeper into our solar system, we're left with a profound question. Are we studying the remnants of alien stellar processes, or are we witnessing our first encounter with technology so advanced that it can masquerade as natural phenomena for billions of years while pursuing objectives we cannot yet comprehend? Chapter 3. The Trajectory Problem. The numbers alone should make any astronomer pause. When 3I Atlas was first detected racing through space at an incomprehensible 255,000 kilometers per hour, the initial calculations revealed something that bordered on the impossible. This wasn't just another interstellar wanderer following a random path through our solar system. The trajectory that 3I Atlas traces through space reads like a masterclass in orbital mechanics, a precision dance choreographed across the vast theater of our planetary neighborhood that would make NASA's mission planners weep with envy. Picture this: an object that has been wandering the galaxy for potentially billions of years, subjected to countless gravitational encounters with stars, planets, and stellar remnants, somehow arrives at our solar system on a flight path so mathematically elegant that it performs precision flybys of Venus, Mars, and Jupiter. Each planetary encounter provides exactly the right gravitational assist to maintain its hyperbolic trajectory while maximizing observational opportunities for Earth-based telescopes. The odds of this happening through pure cosmic coincidence? Approximately 1 in 20,000. These are the same odds that separate a casual lottery ticket from a life-changing jackpot. Space agencies spend years, sometimes decades, planning gravitational assist maneuvers for their most ambitious missions. The Voyager probes required a precise alignment of outer planets that occurs only once every 175 years. The Parker Solar Probe uses 7 Venus flybys over 7 years to gradually spiral closer to the Sun. The complexity of these calculations demands supercomputers, teams of orbital mechanics experts, and multiple backup scenarios to account for even tiny variations in planetary positions. Yet here comes 3I Atlas, an ancient wanderer from another star system entirely, executing what appears to be a textbook example of multi-planetary gravity assist navigation. The first red flag emerged when astronomers realized that 3I Atlas's trajectory lies almost perfectly aligned with the orbital plane of our solar system. Most objects arriving from interstellar space should approach from random directions, reflecting the three-dimensional nature of galactic space and the chaotic gravitational encounters that ejected them from their birth systems billions of years ago. Instead, 3I Atlas approaches at an inclination of just 25.9 degrees from the ecliptic plane, placing it squarely within the zone where our planets reside. This alignment isn't just convenient for observation, it's optimal for gravitational interaction with multiple planetary bodies. The Venus encounter on September 12th provides the first gravitational assist, subtly adjusting 3I Atlas's velocity and trajectory for optimal approach to Mars. The timing couldn't be more precise if it had been programmed by mission control. Mars, positioned exactly where it needs to be for maximum gravitational influence, provides the second course correction on November 2nd, fine-tuning the object's path for the crucial Jupiter flyby scheduled for January 2026. Each planetary encounter occurs at the perfect distance to provide meaningful gravitational influence without disrupting the overall hyperbolic trajectory that will eventually carry 3I Atlas back into interstellar space. But here's where the mathematics become truly unsettling. When orbital dynamicists model the gravitational effects of these planetary encounters, they discover that 3I Atlas's trajectory has been optimized not just for gravitational efficiency, but for observational opportunity. The object will be visible from Earth throughout its entire passage through the inner solar system, never disappearing behind planets or venturing too far from optimal telescope pointing angles. Its brightness curve follows an almost perfect progression, becoming most visible precisely when ground-based and space-based observatories are best positioned to study it in detail. The perihelion passage on October 29th presents another layer of mathematical precision. 3I Atlas will approach within 1.4 astronomical units of the Sun, close enough for substantial solar heating to activate maximum coma production, but not so close as to risk structural disruption. This distance places it in the optimal zone for spectroscopic analysis, where sublimating gases create the most detailed chemical fingerprints, while maintaining sufficient brightness for extended observation campaigns. If you were designing an interstellar probe to maximize scientific return from a flyby of our solar system, this is exactly the trajectory you would choose. The gravitational mechanics involved reveal another troubling detail. For 3I Atlas to achieve its current trajectory through natural means, it would have required a very specific sequence of stellar encounters during its billion-year journey through interstellar space. Computer simulations suggest that only about 0.3% of objects ejected from stellar systems would undergo the precise combination of gravitational slingshots necessary to achieve this particular velocity vector and approach angle. The probability drops even further when you account for the object's chemical composition and apparent age, suggesting formation conditions that occurred when our galaxy was significantly younger and more chaotic. What makes this trajectory problem even more perplexing is the energy efficiency it demonstrates. 3I Atlas carries just enough velocity to complete its gravitational tour of our planetary system without being captured by the Sun's gravity well. Any faster, and it would race through too quickly for detailed observation. Any slower, and it might be pulled into a bound orbit, becoming a permanent resident rather than a visiting messenger. The energy budget is balanced with precision that would impress any spacecraft mission planner, suggesting either extraordinary cosmic coincidence or deliberate design optimized for a specific purpose. The attitude control that 3I Atlas maintains throughout its passage adds another layer of complexity to the trajectory problem. Unlike typical comets, which often tumble chaotically as outgassing creates random thrust forces, 3I Atlas maintains remarkably stable orientation throughout its approach to the Sun. Its rotation period of approximately 7.6 hours remains consistent, suggesting either unusual structural stability or some form of active attitude control that keeps the object properly oriented for optimal solar heating and gas production. Advanced trajectory analysis reveals that 3I Atlas's path through our solar system provides comprehensive reconnaissance of our planetary system's architecture. Its approach angle allows direct observation of Earth-Moon system dynamics, Mars' atmospheric interactions, and Jupiter's magnetic field environment. If you were conducting a systematic survey of a stellar system's habitability and technological development, this trajectory would provide optimal data collection opportunities across multiple planetary environments and potential biosignatures. The departure trajectory proves equally remarkable. After completing its tour of the inner solar system, 3I Atlas will exit at an angle that provides long-term observational opportunities for Earth-based telescopes. Rather than disappearing quickly behind the Sun or into the glare of bright stars, the object will remain trackable for months as it recedes into the outer solar system. This extended visibility window allows for comprehensive analysis of how solar heating affects the object's chemistry, structure, and behavior, precisely the kind of data that would be most valuable for understanding interstellar objects in general. Perhaps most unsettling of all is the realization that if 3I Atlas were indeed under some form of intelligent control, we would have no way of detecting the subtle course corrections required to achieve this trajectory. The same outgassing forces that make the object visible as a comet could easily mask tiny thrust adjustments that would be indistinguishable from natural rocket effects caused by sublimating gases. Any civilization capable of engineering billion-year interstellar missions would presumably have mastered the art of making artificial acceleration indistinguishable from natural phenomena. The trajectory problem of 3I Atlas forces us to confront an uncomfortable question about the nature of coincidence in our universe. How many times can extraordinary mathematical precision masquerade as natural phenomenon before we must consider alternative explanations? The object's path through our solar system demonstrates the kind of orbital mechanics expertise that human civilization has developed only within the last few decades, yet supposedly represents the random wandering of an ancient chunk of ice and rock through galactic space. As 3I Atlas continues its precisely choreographed dance through our planetary system, each passing day brings new confirmation that this trajectory represents either the most remarkable cosmic coincidence in human observation or something far more deliberate than our current scientific framework allows us to admit. The question isn't whether the mathematics make sense. They make perfect sense for a carefully planned reconnaissance mission. The question is whether we're brave enough to consider what such planning might imply about intelligence, patience, and purposes that operate on timescales we can barely comprehend. Chapter 4. The Vanishing Act. The most unsettling aspect of 3I Atlas isn't what we can observe, but what we're about to lose the ability to see. In late October 2025, this mysterious interstellar visitor will execute what astronomers call a solar conjunction, disappearing behind our sun for several crucial weeks, just as it reaches its most active phase. This isn't merely an inconvenient observational gap in our cosmic surveillance. It represents the perfect window for something under intelligent control to shed its carefully maintained disguise and reveal its true purpose. The timing feels almost cruelly deliberate. After months of intensive observation campaigns involving the world's most sophisticated telescopes, 3I Atlas will vanish precisely when it should become most interesting. Perihelion, the closest approach to the Sun, typically triggers the most dramatic changes in cometary behavior. Solar heating intensifies sublimation processes, causing nuclei to shed material at accelerated rates, while potentially exposing deeper compositional layers that have remained frozen for billions of years. Yet, during this critical period, Earth-based astronomy will be effectively blind, unable to monitor whether 3I Atlas continues to behave like the natural comet it appears to be. The mechanics of solar conjunction create an observational dead zone that extends far beyond simple line-of-sight blocking. The Sun's electromagnetic interference overwhelms sensitive instruments, while scattered solar radiation creates a brilliant halo that drowns out faint objects in the surrounding sky. Radio telescopes that might detect artificial signals encounter similar challenges, as the Sun becomes an overwhelming source of natural radio noise that masks subtler emissions from nearby objects. Even space-based observatories positioned away from Earth face significant limitations when attempting to observe objects close to solar proximity. Consider the operational reality of tracking 3I Atlas through this critical period. The Hubble Space Telescope, which has provided some of our most detailed images of the interstellar visitor, must orient itself to avoid direct solar exposure that could permanently damage its sensitive instruments. The James Webb Space Telescope faces similar constraints, with sun shields designed to protect its infrared detectors from the thermal radiation that would overwhelm their extraordinary sensitivity. Ground-based observatories around the world will find themselves unable to point their telescopes anywhere near the Sun's position without risking catastrophic equipment damage. This observational blackout creates what intelligence analysts would recognize as the perfect operational window for covert activity. If 3I Atlas were indeed some form of advanced reconnaissance probe, the solar conjunction period would provide ideal cover for activities that need to remain hidden from terrestrial observation. Deployment of secondary objects, transmission of data back to some distant intelligence, or activation of systems that have remained dormant throughout the long interstellar journey, all could occur during these weeks of enforced astronomical blindness. The precedent for such timing in natural phenomena raises uncomfortable questions about coincidence versus design. Many of the most significant changes in cometary behavior occur precisely during perihelion passage, when solar heating reaches its peak intensity. Ice reservoirs that have remained stable for millions of years suddenly begin sublimating, creating dramatic increases in coma size and brightness. Surface layers that have protected deeper materials from cosmic radiation processing may erode away, exposing primordial ices that carry chemical signatures from the object's original formation environment. These natural processes provide perfect camouflage for any artificial systems that might choose this moment to become active. The energy environment near perihelion offers another layer of strategic advantage for hypothetical artificial systems. Solar radiation flux increases dramatically as 3I Atlas approaches to within 1.4 astronomical units of the Sun, providing abundant energy for systems that might have been operating in minimal power mode during their billion-year interstellar journey. Radioisotope thermal generators that could have sustained basic functions across cosmic time might suddenly have access to solar power levels sufficient for more intensive operations. Communication systems, manufacturing processes, or deployment mechanisms that required significant energy inputs could become feasible for the first time since the object left its original stellar system. The physics of solar heating creates additional opportunities for concealed activity. As 3I Atlas warms, natural outgassing will accelerate, creating an expanding coma of water vapor, carbon dioxide, and dust that could mask the thermal signatures of artificial processes. The chaotic dynamics of sublimating materials provide natural explanations for almost any form of mass ejection or structural change that might occur during this period. Small objects separating from the main nucleus would be indistinguishable from natural fragmentation processes that commonly affect comets during close solar approaches. Current spacecraft positioning adds another dimension to the observational challenge. The Parker Solar Probe, humanity's closest approach to the Sun, follows an elliptical orbit that may or may not position it optimally for 3I Atlas observation during the critical conjunction period. Even if alignment were perfect, the probe's instruments are designed for solar rather than cometary observation, limiting its effectiveness for detecting the subtle anomalies that might distinguish artificial from natural phenomena. Other deep space missions lack the trajectory flexibility to provide alternative observational platforms during the crucial weeks when Earth-based astronomy goes dark. The historical precedent of previous solar conjunctions demonstrates how effectively this natural phenomenon can hide significant cosmic events. Solar flares, coronal mass ejections, and other stellar phenomena have gone undetected during conjunction periods, only to be inferred afterward through their effects on space weather and planetary magnetospheres. If natural solar processes can escape direct observation during these periods, artificial activities operating at much smaller scales could remain completely undetectable, leaving no trace of their occurrence once normal observational capabilities resume. The recovery period following conjunction presents its own set of interpretive challenges. When 3I Atlas emerges from behind the Sun and becomes observable again, any changes in its behavior, composition, or structure could be attributed to the intense solar heating it experienced during perihelion. Natural explanations would exist for almost any observed modifications: increased activity levels, altered gas production rates, surface changes, or even structural fragmentation. Distinguishing between natural solar processing and hypothetical artificial modifications would require extraordinarily subtle analysis of spectroscopic and imaging data. The communication implications of this observational gap extend beyond scientific inconvenience to potential security concerns. If 3I Atlas were indeed artificial and chose to transmit information during the conjunction period, those signals would be completely masked by solar radio emissions. No Earth-based receiver could detect structured transmissions occurring so close to our overwhelmingly bright radio source. The perfect timing for covert communication with some distant intelligence, free from any possibility of terrestrial interception or analysis. The psychological dimension of this enforced waiting period deserves recognition alongside its technical challenges. After months of intensive observation and analysis, the astronomical community will be reduced to passive anticipation, unable to monitor the most potentially revealing phase of 3I Atlas's solar system passage. The natural human tendency to imagine what might be occurring beyond our perception could amplify both legitimate scientific curiosity and unfounded speculation about exotic possibilities. Yet perhaps the most unsettling aspect of the vanishing act isn't what might happen during the conjunction period, but what it reveals about the fundamental limitations of our cosmic surveillance capabilities. Despite our sophisticated telescopes, global coordination networks, and advanced analysis techniques, we remain vulnerable to simple geometric blind spots that can hide the most significant events. The same solar radiation that makes life possible on Earth also creates observational shadows, where the most important cosmic phenomena might unfold completely beyond our awareness. As 3I Atlas approaches this critical period of invisibility, the weight of unanswered questions grows heavier. Will the object that emerges from behind the Sun be the same ancient natural comet that disappeared into solar glare? Or will subtle changes in its behavior, composition, or trajectory suggest that something more significant occurred during those crucial weeks when human observation was impossible? The answers will determine whether our understanding of this interstellar visitor remains comfortably within the bounds of natural explanation, or whether we must confront possibilities that challenge our assumptions about intelligence, technology, and our place in a universe that may be far more purposeful than we dare imagine. Chapter 5. Ancient Intelligence: Modern Implications. The numbers alone are enough to make your head spin. When we speak of 3I Atlas potentially originating from our galaxy's thick disk, we're not just talking about distance. We're talking about time itself, bending around this cosmic wanderer in ways that challenge human comprehension. If the current estimates prove correct, this object has been traveling through the void for somewhere between 5 to 10 billion years. To put that in perspective, 3I Atlas may have begun its interstellar journey when our entire solar system was nothing more than a diffuse cloud of gas and dust, long before the Sun ignited, long before Earth formed, and incomprehensibly long before the first spark of life emerged from primordial oceans. This isn't just ancient, it's prehistorically ancient on a galactic scale. During 3I Atlas's billion-year odyssey through the cosmic dark, entire civilizations could have risen from nothing, achieved technological mastery, explored their local stellar neighborhoods, and vanished into extinction countless times over. The Roman Empire lasted roughly 1,500 years. Human civilization from the first agricultural settlements spans perhaps 10,000 years. Our technological age covers mere centuries. Yet 3I Atlas has been wandering the galaxy for potentially 1,000,000 times longer than the entirety of recorded human history. The implications of this temporal abyss become even more staggering when we consider what it means for any intelligence that might have created such an object. But here's where our investigation takes a turn toward the genuinely unsettling. If 3I Atlas were indeed artificial, representing some form of ancient technology rather than natural formation, we would be confronting evidence of engineering capabilities that dwarf anything in human experience. Think about the most durable artifacts our species has created: the pyramids of Egypt, certain radioactive isotopes, some of our deep space probes. These represent our pinnacle achievements in creating objects designed to last. The pyramids might endure for tens of thousands of years. Plutonium-239 has a half-life of 24,000 years. Voyager 1 and 2, our most distant technological ambassadors, carry power sources designed to function for perhaps a few decades more before falling silent in the interstellar medium. Yet the hypothetical engineering requirements for maintaining any form of active technology across billion-year timescales would demand materials science more advanced than diamond, energy systems more durable than stars, and information processing architectures that could adapt and self-repair across geological epochs. We're talking about technology that would need to remain operational longer than most stellar life cycles, more persistent than mountain ranges, more enduring than continental drift. The very concept pushes against the boundaries of what we consider physically possible, even in principle. This brings us to one of the most chilling possibilities our investigation must confront. What if 3I Atlas represents not active alien intervention, but the ghost of some long-extinct civilization? Picture this scenario: an intelligence that achieved interstellar capabilities billions of years ago, when our galaxy was young and chaotic, when stellar populations differed dramatically from what we observe today. This hypothetical civilization possessed technological prowess sufficient to launch objects on billion-year missions between the stars, encoding them with purposes and directives we can barely imagine. But here's the terrifying twist: the minds that conceived and launched this ancient wanderer may no longer exist. Consider the profound loneliness of such a scenario. Autonomous systems following programmed directives across deep time, perhaps no longer serving any living intelligence, but continuing to execute their original mission parameters with the mechanical precision of clockwork wound up eons ago. 3I Atlas becomes not a harbinger of alien contact, but a cosmic archaeological artifact, physical evidence of intelligence that solved the technical challenges of interstellar engineering, but ultimately succumbed to whatever great filter claimed their civilization. The probe continues its ancient mission across the stellar graveyard, where its creators once thrived, carrying messages from minds that have been dust for longer than our solar system has existed. The Great Filter hypothesis takes on new dimensions when viewed through this temporal lens. Robin Hansen's concept suggests that somewhere in the evolutionary chain from simple chemistry to spacefaring civilization, there exists a step so improbable, so difficult, or so dangerous that virtually all attempts to pass through it result in failure. But what if the filter isn't about achieving interstellar capability? What if it's about surviving long enough to see your probes reach their destinations? Any civilization capable of launching billion-year missions would have solved numerous technical challenges that we haven't even begun to address. They would possess mastery over materials at the atomic level, energy generation and storage at cosmic scales, and information processing across deep time. Such capabilities would seem to offer protection against many potential extinction scenarios, resource depletion, environmental collapse, even conventional warfare. Yet if 3I Atlas were their creation, and if it represents the only evidence we observe of their existence, what great filter might have claimed them despite their technological prowess? The possibilities are sobering to contemplate. Perhaps they fell victim to resource depletion on a galactic scale, expanding so rapidly that they consumed the energy and materials necessary for their civilization's survival. Resource management becomes exponentially more complex when your civilization spans multiple star systems, when your supply chains stretch across light years, and when the feedback loops that might warn of impending scarcity operate on timescales measured in millennia rather than fiscal quarters. Maybe they encountered other intelligences that proved hostile, triggering conflicts that destroyed both aggressor and defender in cosmic scale warfare, that left nothing but automated systems to continue ancient missions. The dark forest hypothesis suggests that advanced civilizations might remain deliberately hidden, operating under the assumption that revealing one's existence could invite predation from even more advanced neighbors. In such a universe, first contact becomes not an opportunity for communication, but a death sentence delivered by entities whose technological capabilities exceed the victim's ability to comprehend, let alone resist. More unsettling still, they might have succumbed to internal contradictions inherent in advanced technological civilization. The same capabilities that allowed them to engineer interstellar probes might have enabled forms of warfare, environmental destruction, or social collapse that proved impossible to control. History offers numerous examples of civilizations that developed technologies more rapidly than the wisdom to use them safely. Our own species currently faces several such challenges: nuclear weapons that could sterilize continents, climate change driven by industrial processes, artificial intelligence systems that might eventually exceed human control. But perhaps the most haunting possibility is that the Great Filter doesn't involve catastrophic destruction at all, but rather evolutionary transcendence. Maybe sufficiently advanced civilizations inevitably transform themselves in ways that render them unrecognizable or undetectable to emerging species like ourselves. They might upload their consciousness into quantum computing systems that operate on principles we can't yet comprehend, merge with their technology so completely that the distinction between intelligence and artifact disappears, or ascend to higher dimensions of existence that remain invisible to our current sensory apparatus. In such scenarios, 3I Atlas becomes a cosmic fossil, the last physical remnant of intelligence that achieved technological capabilities we can barely imagine, then evolved beyond the need for physical form or material interaction. The object continues its billion-year mission, not because living minds still guide its purpose, but because it represents the final material expression of consciousness that has moved on to forms of existence we lack the conceptual framework to recognize. The cosmic perspective required to contemplate these possibilities induces a kind of temporal vertigo. Our galaxy contains roughly 400 billion stars, many of which formed billions of years before our sun ignited its nuclear fires. If even a tiny fraction of those stellar systems produced technological civilizations, the galaxy should have been thoroughly explored and potentially colonized multiple times over during 3I Atlas's wandering. The absence of obvious alien presence, what astronomers call the Great Silence, demands explanation that grows more urgent with each passing decade of SETI searches that return only cosmic static. As 3I Atlas continues its passage through our solar system, carrying within its nucleus whatever chemical signatures and ancient memories remain from its birthplace around another star, we're forced to confront the possibility that we might be alone, not by cosmic accident, but by cosmic inevitability. That intelligence capable of interstellar engineering represents not the beginning of galactic colonization, but its final expression before transformation into something beyond our ability to detect or understand. Whether this scenario proves true or merely represents the fevered imagination of minds grappling with cosmic loneliness, 3I Atlas serves as a tangible reminder that the universe operates on scales of time and space that dwarf human experience, while following laws precise enough to predict this visitor's location years in advance. In that mathematical predictability lies both comfort and cosmic horror, the reassurance that physical laws remain constant across the galaxy, and the unsettling possibility that they also govern the rise and fall of intelligences we may never have the opportunity to meet. Chapter 6. The Response Protocols. The global astronomical community's response to 3I Atlas has been nothing short of remarkable. A carefully choreographed dance of international cooperation, cutting-edge technology, and scientific precision that rivals the most ambitious space missions ever undertaken. Within hours of the initial detection on July 1, 2025, telescope networks spanning 6 continents had swung into coordinated action, tracking this ancient wanderer with the kind of unified focus typically reserved for approaching asteroids that threaten Earth. Yet beneath this impressive display of human collaboration lies a more unsettling question. What happens when our carefully crafted protocols encounter something that doesn't fit the comfortable categories of natural phenomena? The immediate response followed decades-old procedures with clockwork precision. Chile's ATLAS survey detected the anomalous moving object and automatically flagged it for follow-up observations. Within 6 hours, the Minor Planet Center at Harvard-Smithsonian had received confirmation from 3 independent observatories and issued the preliminary designation. NASA's Planetary Defense Coordination Office ran impact probability calculations that quickly ruled out any collision threat. The European Space Agency's Space Situational Awareness Program added its tracking capabilities to the growing network of observers. This is modern astronomy at its finest, a global nervous system of sensors and analysts working together to make sense of cosmic visitors. But imagine, for a moment, that future observations begin to reveal signatures that challenge our fundamental assumptions about what constitutes natural behavior in space. Suppose the Hubble Space Telescope, during one of its priority target of opportunity observations, captures something that looks suspiciously like controlled structural changes on 3I Atlas's surface. Maybe the James Webb Space Telescope's infrared sensors detect thermal patterns that don't correlate with solar heating, organized hotspots that suggest internal activity rather than passive warming. Perhaps most unsettling of all, what if radio telescopes monitoring the object begin to pick up faint but undeniably artificial signals, brief transmissions that occur only when 3I Atlas is positioned between specific planets, as if it's reporting back to some distant intelligence about our solar system's architecture? The institutional stress test that would follow such discoveries has never been attempted in human history. Our current frameworks for handling extraordinary astronomical claims were developed for gradual revelations, not paradigm-shattering confirmations of non-human intelligence operating in our immediate cosmic neighborhood. The International Astronomical Union's protocols require independent verification from multiple observatories before accepting results that challenge established understanding. But what happens when the phenomenon being verified represents active alien technology? How do you maintain scientific objectivity while acknowledging the possibility that you're documenting humanity's first contact with non-terrestrial intelligence? The political dimensions would escalate beyond anything our diplomatic institutions have ever navigated. Every major power on Earth would suddenly view 3I Atlas through the lens of national security rather than scientific curiosity. Military establishments that currently regard space primarily as a domain for satellites and missile defense would confront the reality of potentially superior technology already operating within our solar system. The delicate balance between transparency and security that has generally favored openness in astronomical research might shift dramatically toward classification and restricted access. Scientists who had spent their careers sharing discoveries freely through international journals and conferences could find themselves bound by security clearances and non-disclosure agreements. The communication challenges would prove equally daunting. How do you announce to 7 billion people that their scientific institutions have confirmed the presence of artificial intelligence in their solar system without triggering mass panic or social collapse? The measured, careful language that space agencies have used to describe 3I Atlas, emphasizing its scientific interest while downplaying sensational interpretations, would need to evolve rapidly to handle claims that exceed every previous category of human experience. The 24-hour news cycle's appetite for dramatic developments would clash with the necessarily cautious pace of scientific verification, creating perfect conditions for misinformation and conspiracy theories to flourish alongside legitimate reporting. Consider the technical realities of responding to confirmed alien presence in our solar system. Our fastest spacecraft take years to reach the outer planets where 3I Atlas currently resides, and decades to achieve the velocities necessary for interstellar pursuit. If the object were indeed under intelligent control and time-sensitive communication were desired, our only practical option would be powerful radio transmissions aimed at its current position. But even this assumes the alien technology uses communication protocols we could recognize or decode, a massive leap of faith given our complete ignorance of how advanced civilizations might structure their information systems. The absence of any realistic interception capability highlights humanity's current limitations in space technology. Despite decades of impressive achievements in robotic exploration, we remain firmly confined to our immediate solar neighborhood, with transit times measured in years rather than months. The New Horizons probe, traveling at over 50,000 kilometers per hour, still took 9 years to reach Pluto. 3I Atlas moves 5 times faster and will be beyond our reach within months of any hypothetical discovery of artificial signatures. The window for meaningful interaction would close before we could develop adequate response capabilities. Previous false alarms have taught valuable lessons about managing extraordinary claims in the age of instant global communication. The famous "wow" signal, detected by SETI researchers in 1977, generated enormous initial excitement, but ultimately proved to be a one-time event that couldn't be independently confirmed or replicated. More recently, the unusual acceleration of Oumuamua led to brief speculation about artificial propulsion before conventional explanations involving outgassing emerged to explain the observations. Each of these episodes has refined the scientific community's approach to balancing legitimate investigation of anomalous phenomena with the need to avoid premature conclusions that could damage public trust in scientific institutions. The media management component of any response to confirmed alien technology would require unprecedented coordination between scientific institutions, government agencies, and international organizations. Social media platforms would face enormous challenges, distinguishing between verified updates from legitimate sources and the inevitable flood of hoaxes, conspiracy theories, and misinterpretations that would accompany such momentous news. The algorithms that currently govern information flow on these platforms prioritize engagement over accuracy, potentially amplifying dramatic but unfounded claims at the expense of careful scientific analysis. Educational institutions would confront immediate pressure to revise curricula, research priorities, and fundamental assumptions about humanity's place in the universe. Universities that have spent centuries developing expertise in terrestrial phenomena would suddenly need to incorporate confirmed non-human intelligence into their understanding of reality. Philosophy departments would grapple with questions about consciousness and intelligence that were previously theoretical. Anthropology programs would need to expand their definition of culture beyond terrestrial boundaries. Even economics courses would require updates to account for the potential technological disruptions that confirmed alien science might bring to human industry and commerce. The timeline constraints imposed by 3I Atlas's trajectory add urgency to any hypothetical response scenario. Unlike the gradual approach of most astronomical phenomena, interstellar visitors arrive and depart according to the inflexible schedule of celestial mechanics rather than human convenience. Any meaningful response to confirmed artificial origin would need to be developed, coordinated, and implemented within months, rather than the years that complex international agreements typically require. This compression of normal decision-making processes would test every aspect of our institutional capabilities under circumstances where the stakes are high, could involve humanity's long-term relationship with non-terrestrial intelligence. Yet the actual response to 3I Atlas has demonstrated remarkable efficiency within these constraints. The global astronomical community identified the object as interstellar, confirmed its harmless trajectory, coordinated multi-wavelength observations across 6 continents, and began detailed chemical analysis within weeks of initial discovery. This track record suggests that existing institutions and procedures, while imperfect, provide a solid foundation for handling even unprecedented discoveries. The transparent sharing of observational data, the rapid publication of results, and the international cooperation that has characterized the investigation represent humanity's scientific collaboration at its most effective. The theoretical frameworks for responding to confirmed alien contact have been evolving for decades through the work of SETI researchers, astrobiologists, and international legal scholars. While these preparations couldn't address every contingency of actual first contact, they provide starting points for the kinds of rapid decisions that would be necessary under extraordinary circumstances. The protocols emphasize caution, verification, and international consultation, principles that align well with the measured approach that has characterized the 3I Atlas investigation. Perhaps most importantly, the response to 3I Atlas has demonstrated that humanity possesses both the technical capabilities and institutional frameworks necessary to study unprecedented phenomena effectively. The combination of space-based telescopes, ground-based observatories, rapid global communication, and established scientific peer review has enabled comprehensive analysis of this ancient visitor within an remarkably short time frame. Whether these same capabilities would prove adequate for actual confirmation of alien intelligence remains an open question. But the coordinated professional response to 3I Atlas provides reason for cautious optimism about our species' ability to handle even more transformative cosmic encounters. As 3I Atlas continues its journey through our solar system, the protocols developed for studying this remarkable visitor will serve as templates for investigating future interstellar objects that may prove even more challenging to our understanding of what's possible in the cosmos. Chapter 7. The Fermi Whisper. The question echoes through every astronomical discovery, lurking behind every search for extraterrestrial intelligence, haunting every moment when we peer into the cosmic darkness and find only silence. Enrico Fermi posed it during a casual lunch conversation in 1950, but its implications have only grown more profound as our understanding of the universe has expanded. If the galaxy should be teeming with intelligent civilizations, if the cosmos offers countless opportunities for life to arise and evolve, then where is everybody? This Fermi paradox takes on chilling new dimensions when we consider interstellar objects like 3I Atlas, because each visitor from beyond our solar system should eventually reveal something extraordinary, evidence of the technological civilizations that logic says must exist among the stars. Picture this unsettling reality. Our galaxy contains roughly 400 billion stars, many of which formed billions of years before our sun ignited. Even if a conservative 1% of those stellar systems produced technological civilizations, the galaxy should have been thoroughly explored and colonized thousands of times over. Yet when 3I Atlas arrives, carrying chemical signatures from these ancient stellar neighborhoods, it whispers only of natural processes and empty space. The silence grows more deafening with each interstellar visitor we study, each one arriving as a natural wanderer rather than an artificial herald of distant intelligence. 3I Atlas represents our third confirmed interstellar visitor, following Oumuamua in 2017 and 2I/Borisov in 2019. And the pattern that emerges should disturb anyone who contemplates our cosmic solitude. Each object displays fascinating properties that initially spark speculation about artificial origins, yet each ultimately reveals itself as thoroughly natural. Oumuamua's unusual elongated shape and slight acceleration created brief excitement about possible alien technology before natural explanations emerged. 2I/Borisov behaved exactly like a conventional comet, despite its interstellar origins. Now 3I Atlas brings unprecedented carbon dioxide chemistry that challenges our understanding of comet formation, yet shows no signs of artificial design or intelligent control. This accumulating silence carries implications far more unsettling than any science fiction invasion scenario. If advanced civilizations routinely arose throughout galactic history, interstellar space should be thick with their artifacts. Ancient probes should drift between the stars, some still operational after millions of years, others dormant but recognizably artificial. The absence of such objects suggests either that technological civilizations are extraordinarily rare, or that something prevents them from spreading throughout the galaxy. The Fermi whisper grows louder with each natural visitor, like 3I Atlas, reminding us that in a universe that should echo with intelligence, we hear only our own voices calling into the dark. Consider the engineering implications of what we're not finding. Any civilization capable of interstellar travel would possess technologies that dwarf our current capabilities. They would understand materials science at the atomic level energy generation at stellar scales, and information processing across geological time. Such civilizations would likely send probes to survey nearby stellar systems, much as we've begun exploring our own solar neighborhood with robotic spacecraft. These artificial wanderers would carry unmistakable signatures of their technological origin, coherent radio transmissions, engineered materials with impossible isotope ratios, controlled trajectories that violate natural orbital mechanics. Yet, when sophisticated instruments examine objects like 3I Atlas, they find only the signatures of natural processes operating according to universal physical laws. The carbon dioxide that makes this interstellar visitor chemically unusual reflects formation conditions around ancient stars, not artificial engineering. Its trajectory follows the predictable mathematics of gravitational interactions rather than controlled navigation. Its thermal signatures match natural heating by solar radiation rather than internal power sources. The absence of artificial markers in such a thoroughly studied object should force us to confront uncomfortable questions about intelligence in the cosmos. The energy requirements for interstellar communication and travel may provide clues to this cosmic silence. Broadcasting signals powerful enough to be detected across typical interstellar distances would require energy outputs comparable to small stars. Even highly directional transmissions, focused like searchlight beams toward specific target systems, would demand power generation capabilities far beyond anything currently achievable by human technology. These physical constraints may explain why SETI searches have found no convincing artificial signals, despite decades of listening across vast ranges of frequencies and stellar directions. The same energy considerations apply to interstellar travel, providing context for why objects like 3I Atlas arrive as natural wanderers rather than artificial probes. Accelerating even a small spacecraft to the velocities required for rapid interstellar transit would require energy equivalent to the total annual power output of major industrial nations. Larger vessels would demand correspondingly greater energy investments, potentially exceeding the entire energy production capability of advanced technological civilizations. These harsh physical realities may explain why the galaxy remains apparently empty of obvious artificial travelers. Our own species provides a sobering example of technological development constrained by energy and resources. Despite remarkable achievements in space exploration, we remain firmly confined to our immediate solar neighborhood, with robotic missions taking years to reach the outer planets and decades to achieve interstellar velocities. If civilizations throughout the galaxy face similar constraints, the absence of obvious artificial visitors becomes more understandable, though no less lonely in its implications. The radio bubble that announces humanity's presence to the cosmos illustrates our cosmic insignificance on galactic scales. Since Marconi's first wireless transmissions in the late 19th century, our radio signals have been expanding outward at the speed of light, currently reaching stars within roughly 120 light-years of Earth. This seems impressive until we realize that our galaxy spans roughly 100,000 light-years in diameter, making our radio presence a tiny whisper in the vast galactic conversation we hoped to join. Even if 3I Atlas carried listening devices sensitive enough to detect our electromagnetic signatures, the object's apparent billion-year age means it began its journey long before Earth supported any form of technological civilization. The statistical implications of interstellar object discoveries provide another piece of this cosmic puzzle. If planetary system formation routinely ejects significant quantities of rocky and icy debris, as computer simulations suggest, then the galaxy should contain trillions of wandering objects, like 3I Atlas. The discovery rate of several interstellar visitors per year that next-generation surveys should achieve represents only the tiniest sampling of this vast population, limited by the constraints of detection technology and observational coverage. This statistical perspective suggests that even if artificial probes exist among the wandering population, they might remain hidden in a background of natural objects that greatly outnumber any technological artifacts. Yet this explanation only deepens the mystery rather than resolving it. If advanced civilizations have had billions of years to develop and spread throughout the galaxy, they should have produced enough artificial wanderers to appear in our growing sample of interstellar visitors. The continued absence of obvious technological signatures in objects like 3I Atlas forces us toward increasingly uncomfortable conclusions about our cosmic isolation. Either we are among the first technological species to arise in our galactic neighborhood, or something prevents civilizations from surviving long enough to spread between the stars. The Great Filter Hypothesis provides one framework for understanding this cosmic silence, suggesting that somewhere in the long chain of evolutionary development, from simple chemistry to spacefaring civilization, there exists a step so improbable or dangerous that virtually all attempts to pass through it result in failure. This filter might occur early in the process, perhaps in the transition from non-living matter to self-replicating systems, making life itself extraordinarily rare throughout the cosmos. Alternatively, the barrier might emerge later, when civilizations develop technologies powerful enough to destroy themselves faster than they can learn to use them wisely. The possibility that we are witnessing the universe in its youth, before intelligence has had sufficient time to spread and flourish, offers another explanation for the silence that surrounds us. If technological civilizations only recently began arising throughout the galaxy, the absence of obvious artificial signatures in ancient wanderers like 3I Atlas becomes more understandable. We might be among the early adopters of technology in a universe that will eventually teem with intelligence, but which currently echoes with the loneliness of isolated worlds just beginning to reach toward the stars. As 3I Atlas continues its billion-year journey through the galactic dark, carrying within its nucleus only the chemical signatures of natural stellar processes, it serves as a cosmic messenger, delivering news of our profound solitude. The silence it brings is not the comfortable quiet of an empty house, but the unsettling hush of a vast cathedral where countless voices should be singing, yet only our own hesitant whispers echo back from the cosmic architecture. In this silence lies perhaps the strangest worst-case scenario of all. Not that we are threatened by alien intelligence, but that we may be utterly alone in our small corner of an indifferent universe, calling out to civilizations that either never arose or have long since fallen silent beneath the weight of challenges we have yet to face. Chapter 8. The strangest scenario of all. As we reach the final chapter of our investigation into 3I Atlas, we must confront perhaps the most unsettling revelation of all. After exploring scenarios involving ancient alien technology, billion-year surveillance missions, and cosmic intelligence beyond human comprehension, the evidence continues to point toward a conclusion that might be stranger than any science fiction we could imagine. 3I Atlas is exactly what it appears to be. This shouldn't disappoint us. In fact, it should fill us with a profound sense of wonder that transcends any Hollywood spectacle. Here, racing through our solar system at impossible speeds, is a genuine messenger from another star system, carrying within its ancient nucleus the chemical fingerprints of stellar environments that existed billions of years before our sun ignited. The carbon dioxide that dominates its coma isn't evidence of alien engineering. It's something far more remarkable. It's the breath of another world, preserved across geological time and delivered to our cosmic doorstep. Think about the journey this object has undertaken. While Earth was still a molten ball of rock, while life was taking its first tentative steps in primordial oceans, while entire civilizations of dinosaurs rose and fell, 3I Atlas was already wandering the galaxy. It has witnessed stellar births and deaths, passed through regions of space where the very atoms in our bodies were still locked away in ancient stars. It carries information about the thick disk of our galaxy, that older generation of stars that formed when the Milky Way was young and chaotic, when the chemical composition of space itself differed dramatically from what we observe today. The mathematical precision with which we've tracked its trajectory, predicted its behavior, and understood its composition represents one of science's greatest triumphs. When Chilean astronomers first detected this speck of light on July 1st, 2025, they weren't just discovering another space rock. They were witnessing the intersection of human knowledge with cosmic scale. The moment when our understanding of physics proved capable of comprehending phenomena that span billions of years and countless light years of space. Yet throughout our investigation, we've repeatedly found ourselves drawn to more exotic explanations. Ancient alien probes, surveillance networks, technological artifacts from civilizations that died out before our solar system formed. These speculative scenarios have served their purpose, forcing us to think carefully about what distinguishes natural from artificial phenomena in space, encouraging the development of observational tests that could falsify our assumptions, and reminding us that the universe may still hold surprises that challenge our current understanding. But the most profound surprise of all might be that no exotic explanation is required. The universe has proven strange and wonderful enough through natural processes alone. From quantum mechanics to black holes, from dark energy to the cosmic web of large-scale structure, reality consistently exceeds our imagination without requiring artificial additions. Perhaps our tendency to seek alien explanations for unusual phenomena says more about us than it does about the cosmos, revealing both our deep loneliness in the universe and our almost desperate hope that we're not alone among the stars. The coordinated international response to 3I Atlas has demonstrated humanity at its collaborative best. Within days of discovery, observatories worldwide were contributing data, space telescopes were providing detailed analysis, and researchers were sharing results through open archives that made this investigation accessible to anyone with curiosity and an internet connection. This transparency, this commitment to shared knowledge that transcends national boundaries and institutional affiliations, represents our highest aspiration for engaging with cosmic mysteries. The James Webb Space Telescope's revelation of 3I Atlas's unusual chemistry didn't trigger panic or secrecy. It sparked excitement and deeper investigation. The Hubble Space Telescope's exquisite images weren't classified or hidden, but shared with the world through public archives. Amateur astronomers contributed their own observations. Students analyzed the data in classrooms, and citizen scientists participated in monitoring campaigns that enriched our collective understanding. This democratic spirit of discovery provides hope for how humanity might handle even more extraordinary cosmic encounters in the years ahead. Should astronomers eventually detect genuinely anomalous objects that challenge our understanding of natural processes, the precedent set by 3I Atlas suggests we'll approach them with instruments rather than weapons, with curiosity rather than fear, with collaboration rather than competition. The promise of future discoveries looms large as 3i Atlas continues its journey back into interstellar space. The Vera Rubin Observatory will detect hundreds of similar visitors over the next decade, transforming interstellar objects from rare curiosities into routine astronomical phenomena. Each new discovery will add pieces to the puzzle of galactic evolution, expanding our understanding of the materials and processes that operate around distant stars. Some may prove even more chemically unusual than 3i Atlas. Others might display properties that challenge our assumptions in entirely new ways. But perhaps the greatest lesson 3i Atlas offers isn't about interstellar chemistry or galactic evolution. It's about the power of evidence-based thinking in an age of manufactured uncertainty. While our earthbound world churns with conspiracy theories and artificial controversies, this ancient wanderer has followed laws that transcend human politics and opinion. Its behavior can be predicted with mathematical precision, its composition analyzed through spectroscopy, its origins understood through the universal principles of physics and chemistry. There's something deeply comforting about this cosmic reliability. In an era when truth itself seems negotiable, when facts compete with feelings, when scientific conclusions are treated as matters of opinion, 3i Atlas reminds us that some things remain beyond the reach of human manipulation. The universe operates according to principles that care nothing for our beliefs, our fears, or our desires. It simply is, in all its mathematical majesty and natural wonder. As our investigation draws to a close, 3i Atlas continues its outward journey, fading with each passing day into the star-scattered darkness from which it came. Soon, it will be beyond the reach of our most powerful telescopes, returning to the interstellar medium, where it will wander for perhaps billions more years before chance encounters with other stellar systems alter its trajectory once again. We were privileged to witness this brief cosmic moment, to study this ancient traveler, and to add its story to the growing catalog of wonders that fill the space between stars. The worst-case scenario we set out to investigate, the possibility of cosmic catastrophe or alien invasion, has proven unfounded, replaced by something more subtle but equally profound. The recognition that natural processes can be more remarkable than any artificial construct we might imagine. In seeking alien intelligence among the stars, we discovered something perhaps more valuable: evidence of our own growing intelligence here on Earth, our capacity for international cooperation, our commitment to evidence-based understanding, and our willingness to share cosmic discoveries with all humanity. 3i Atlas has given us a gift that transcends its scientific data. It has provided a case study in how our species approaches the unknown, how we balance skepticism with wonder, how we distinguish between legitimate scientific uncertainty and unfounded speculation. These lessons will serve us well as future cosmic messengers arrive at our doorstep, each carrying its own secrets from the vast galactic wilderness that surrounds our small but remarkable planetary home. Good night, Cosmic Messenger. Thank you for the chemistry lessons, the reminder of cosmic scale, and the demonstration that reality remains far stranger and more beautiful than our earthbound imaginations might suggest. Safe travels on your continued journey through the galaxy, carrying whatever ancient memories remain locked within your nucleus. Testimony to stellar environments that existed long before our world knew the warmth of its own star. Thank you for joining us tonight on this journey through cosmic speculation and scientific wonder. The universe continues to surprise us with its natural majesty, reminding us that truth can be more remarkable than fiction when we take the time to look carefully and think deeply about the phenomena that surround us. If you've enjoyed exploring these cosmic mysteries with us, don't forget to subscribe to the Sleep Lab, where we transform the wonders of science and space into the perfect companion for peaceful sleep. Until our next cosmic adventure, rest well under the same stars that guide ancient wanderers, like Three-Eye Atlas, on their billion-year journeys through the infinite dark.